Yeah, this is Mr. Syed Qadri, physics teacher from Schurz High School. Uh, and I have students who take physics for the first time in their life. They have never studied physics. And I've been teaching there for the last 23 years. I teach both honors and regular physics. And I always had a hard time teaching them some basic concepts, and especially graphing motion and the basic definitions and stuff like that. So I thought this way might be better to actually teach them these concepts. It took me a while, like a month, just to teach them concepts like speed, velocity, acceleration, and then Newton's laws. And with these models that I have made now, I think I wouldn't have to spend more than a week or so, and we can move on faster. My only hope and wish is that I can make more of these models in the content so that I can constantly use these NetLogo, NetTango models that I have made. And so here are some of the models that I have made with the co-design team. And it first starts with a constant velocity, and it's just loading up. It's a NetLogo model where students can actually just set up and go and then plot the three different graphs for displacement versus time, velocity versus time, acceleration versus time. And you can also look at this as a motion map where the car is actually stamping on, or you can actually do this just as the motion of a car as you actually see it without stamps. So students can look at both ways and understand how the car is moving, and then actually what the plots look like. And this can be done with both positive and negative velocity. And so that way they understand that the graphs look different for positive displacement, negative displacement, positive velocity, and negative velocity. So that was the first model. Then the second model that we move on from here is about multiple lane. So I thought, what if instead of having just one lane, one car moving in a lane, what if you have like an expressway where you have three different lanes moving on each side? And will students be able to understand the motion of all these cars together? So here's a model of multiple lane still with constant velocity. You can just set up different constant velocity on these sliders, and you can actually see the motion of the cars, like fast lanes, slower lanes, and you can even look at the motion map by stamping it, and then you can compare these graphs and determine which of these cars are actually speeding over the limit, and so on and so forth. And from this idea, I thought it might be beneficial to introduce the concept of relative velocity, because that's kind of difficult concept the students have a hard time to understand. So I thought it might be worthwhile introducing the concept of a driverless car. How does a driverless car actually see traffic? And I made a simulation on this driverless car, and where you just set up the spacing between the two cars and the speeds of the two cars. You set up and go, and you can actually see both cars moving. And you can look at the graphs and you can determine the actual velocities of the two cars and the relative velocity. Since both cars have the same exact speed, the graphs are overlapping in this case. But if I just change the speed of one of these cars a little bit, then you'd actually see that the cars would move on with different speeds and different velocity, but eventually the cars will end up in a collision, because in a NetLogo model, since the world is wrapped around, the faster car comes around from behind, and then there's an eventual accident. So there are questions, critical thinking questions based on relative motion, relative velocity, and also about modeling with NetLogo, where you cannot really have a real life situation where the two cars are just going in a straight line with their own speeds forever, because the NetLogo world is wrapped around. So this is my first unit that introduces the basic definition of displacement velocity, positive, negative, and then the relative velocity.